A large part of my work was to give credit to those medical people and optometrists who had deep insight about the prevention of a negative state for the normal eye. I try not to fight with them, but I try and get accurate results in science. A large part of this is the so-called ergodic thesis of statistical mechanics, but that does require explanation. Probably the simplest way to do this is talk about time series, where you look at an oscilloscope and look at noise over time. And as shown in the time series or green line for one eye. Now, the statistical issue of Ensemble is to have a series of eyes and rather look at time, take a snapshot of all 17 in this case. And the specific capability of the ergodic theorem is to say that you'll get the same result. I'll show that in the next slide. At my request, Dr. Ronberger took measurements on a series of individuals. That is a snapshot and a series of all eyes that were normal. They had refractive states from 0 to plus 3 diopters. The result was we calculated the left and right and the difference. You then calculate the standard deviation, or RMS, of the ensemble, which is 0.213 diopters. That gives you a noise signature for a control system. I then expanded this into a time series and calculated the RMS of the time series. And again, you have the ID of the person, the OD who did it, Dr. Ronberger, and the age of the various persons. Here's the time series where we take the RMS value and expand it as shown. So you have the values for left and right eye spread out and calculate the RMS noise of each eye, and then the differential noise, which was 0.211 diopters. So this is how you get tracking accuracy of a control system, estimated obviously, but impressive. Again, this test could be repeated with many more measurements, which will improve the accuracy. The basic concept doesn't change, nor does the expected accuracy. Here again is the entire concept. By calculations in a published paper, we found out the eye's tracking accuracies is 1/10 of a diopter. That's incredible accuracy for a control system, since the eye has a total power of 60 diopters. This is the relationship in all normal eyes between the accommodation level in diopters to its refractive state. A recent experimental study of the normal eye showed that the refractive state follows or tracks the accommodation signal within reasonable experimental accuracy. Given the accuracy is 1/10 of a diopter, this is not surprising at all. Again, time series and snapshot ensemble for a large number of values will give you the same result. critical to science, not really used in optometry. Thank you.